Hey guys, Talkaholics, it's Thanksgiving, so I'd like to express my personal gratitude to you for being here today. I'd also like to express my personal gratitude to the material in which I will be talking about today, known as copper. If you would like to reciprocate, please consider clicking that like button. All right, here we go. So the bull case for copper, and the quote I have chosen for today: heads I win, tails I win, even more. The reason I have selected this quote is because I believe many stocks, not all, but many, are already undervalued in current market conditions in the industry. And I also believe that the trajectory which we are on for the material itself is going much, 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 much higher in the coming years. So why do I believe that? Well, for two reasons: the demand for the material itself, which I believe will increase, and the supply for the material itself, which I believe will decrease. So the demand, what I'll be talking about today: electric vehicles, something called intermittent collection energy sources, a term I have coined, which the reason I have chosen this is because I believe in calling a spade, otherwise known as renewable energy sources, and aluminum, and why this is not a viable substitute to copper. Number two, again, the supply. We'll be talking about copper grades and how they've been gradually declining over the past 100 years or so, and the rise of environmentalism, particularly in the United States and Canada. And by the end of this video, you will realize why you should also be a copper bull. So first of all, let's get right to it, right? Electric vehicles. We can see that there's immense popularity in these stocks recently. You can see that Tesla recently is up, I don't know, 30% in the last week. For me, no thank you. To me, I don't need to invest in these extremely overvalued companies. To me, I don't even want to pick a winner at all. I see significant competition for all of these companies, whether it be Tesla, Porsche, which is making amazing electric vehicles, Ford, which is making a fantastic electric truck, and all of these traditional auto manufacturers are just making amazing electric vehicles. So for me, I'm like, do I really need to pick the Henry Ford of the past, the guy who invented the what do you call it, the assembly line, right? I don't need to pick the best of any of these, because I can just instead pick the material that all of these companies are going to need. So, and like I mentioned, I think a little bit before, all of these companies, even considering the growth trajectory, they're already undervalued. So there's just so little downside, right? But copper is essential to electric vehicles, right? So copper is used throughout electric vehicles, the charging stations, which we'll talk a little bit more about in a second, and the supporting infrastructure because of the metal's durability, high conductivity, and efficiency. So down here, we can see this yellow. It's how much copper is used in a traditional conventional vehicle. We would say this would be a exclusively gasoline powered vehicle. Uses somewhere between 18 and 49 pounds of copper. Not insignificant, but you can see this number compared to hybrids, where effectively this copper usage is doubling from the maximum end of copper usage in a traditional vehicle, yeah? And the hybrid vehicles have been increasing in popularity. And when we're talking about purely electric plug-in vehicle, well, not yet, we're talking about plug-in hybrid vehicles, the copper usage is tripling, and then purely electric vehicles is quadrupling compared to a basic conventional vehicle, right? And then if you believe that electric vehicles are really going to take over the world, that we need to absolutely replace our public transportation infrastructure with electric vehicles. I'm not sure how viable these are, but in any case, a hybrid electric bus is going to have to use 200 pounds of this stuff per bus, and a purely electric powered a bus 4 times that amount. So the point of all of this, copper usage in an industry that, yes, is increasing in the Western world, copper usage is going to go up significantly in the coming years, and has already. So in addition, to make all of these electric vehicles really viable, an immense investment in infrastructure is necessary. So what does this mean in particular? To make long distance travel possible, there has to be charging stations, public charging stations. Right? We have these for gasoline powered vehicles. You can drive on any freeway and there's gasoline stations everywhere. Well, to make these, to make electric vehicles convenient, you really need to make them competitive to gasoline powered vehicles. There has to be more and more charging infrastructure. Now, the socialist parties in the United States, Europe, and China have already committed to doing these things. And in the United States in particular, they've been gaining power recently. But if you're interested in more in that stuff, I made a video on how we can exploit Democrats and the Biden to get rich. So check that out if you are interested. But in any case, these infrastructures, they're coming. And what do these infrastructures use? They use the material copper. In addition, if we are going to charge electric vehicles in people's homes, the traditional electric infrastructure is not sufficient. It can't handle everybody on your block charging their Tesla, Porsche, or whatever your favorite electric vehicle company may be. So that, what does that also mean? To upgrade that infrastructure, more copper is going to have to be invested in. So perspective on these copper use in intermittent collective energy sources, sometimes referred to as renewables. When we think about wind and solar, these sources of energy use immense amounts of copper. Here's a couple of examples on how. First of all, every windmill has a generator in it. In that generator, in every single windmill, on a wind farm or wherever it may be that's producing energy, there are almost a ton of copper inside of that generator. In a wind turbine. The shaft from the wind-driven blades are connected to the generator, which creates energy. The generator is connected to cables, which we can see here are often also copper. And this copper wiring, tubing, and cables offer a potential for copper usage up to 5 to 6 times greater than in traditional electrical generation. When we're talking about normal power plants, whether that be coal, oil, natural gas, or nuclear. And there are also approximately 5.5 tons per megawatt of copper in renewable systems. It's an immense amount of copper necessary. Yeah. Also, solar currently it's consuming, as we are producing solar panels today, 2 to 3% of the annual copper supply. This is only going to increase as the popularity of these ICES's renewables increases. Also, there are these things called transformers. Step-up transformers are used to power wind turbines. For these, for the electricity to be transmitted, another ton of copper per transformer to feed the DLO cables from tower base, switchgear, connector lugs, something. So if you guys are engineers and you guys can explain this, let me know. I'm not an engineer. The point of all of this is that just the fact that we are increasing energy production in these kinds of sources is going to use more and more copper. Okay. Here's another, this next slide is kind of visualize, just to visualize how much more copper is going to be used. So we know that every single one of these solar panels, for example, is going to use copper in it, right? Over here, every single one of these wind turbines, and we know that there's a significant amount of copper used in each one of those turbines, right? Now, think about the space, about how much space these kinds of energy sources are using compared to a traditional power plant, right? The amount of physical space between each one of these solar panels, each one of these windmills, is much larger than wherever the generator is compared to wherever it's going to export the energy in a traditional power plant. So what that means, all of these panels and all of these windmills, they need to be connected, right? It doesn't just produce the energy and transmit that energy through the air. All of this energy needs to be transmitted through lines, power lines. So imagine how much copper is going to be used in a solar farm like this, how much copper is going to be used to connect a wind farm like this versus a traditional power plant. Yeah, that's a lot of copper. And so you may hear a case, well, we could just use aluminum, right? And aluminum is an extremely abundant earth metal. And for myself, I was like, you know what, maybe I should research this. I don't know a lot about it. And again, I'm not an engineer, so if you guys can let me know if I'm wrong or if there's something that doesn't make sense to you, let me know in the comments below. But based on my research, no, we cannot use aluminum, and here are some of the reasons why. Yeah? So copper has a significantly lower electrical resistance than aluminum. So it's got 100 versus 160. What this means is that particularly if we're going to use a aluminum wiring versus a copper wiring, the size of an aluminum wire would have to be significantly bigger than a copper wiring. So if we're thinking of all these niche applications inside of a windmill, inside of a solar panel, you need smaller copper wiring, right? So in addition, copper has a lower coefficient of thermal expansion. So we think about heat in these wires, right? This parameter measures the tendency of a material to change in volume as a function of temperature. So what we're talking about here is as these wires heat up, copper, it doesn't tend to increase in size as it heats up as much as we're talking about aluminum. So aluminum already has to be larger to transmit the same amount of energy. And as it heats up, and it will heat up as electricity passes through it, it's going to have to increase also. So that, again, if we're talking about size-specific applications, aluminum is not going to be a substitute for copper, right? In addition, corrosion, not really an issue for copper. So when we're talking about copper, it can oxidize. If you think about the, we're talking about it can corrode. When we're talking about, for example, the Statue of Liberty, it has that has famous green color, right? It is corroding, not particularly because of oxygen, but because of carbon dioxide exposure. It turns a green color. But when we're thinking about electricity, this corrosion is still conductive. So when we're thinking about maintenance on a solar farm or a wind farm, that corroded copper is still going to transmit electricity. Aluminum, on the other hand, when it oxidizes, that oxide layer, it doesn't conduct. It's non-conductive. It doesn't conduct electricity at all. So the outer layer of aluminum wiring, as it is exposed to the elements, it doesn't transmit electricity. This copper also shows good resistance to creep. So creep is kind of like this concept where a material is exposed to a constant force. So often it's when we're talking about materials and engineering, it's the kind of the for example, if we have a bridge, right, and that bridge has vehicles going over it constantly, over and over and over and over and over, it's not a strenuous force on its own, but over time you have this constant force, right? So copper is highly resistant to any kind of gradual force. Aluminum, on the other hand, is highly susceptible to creep. So these forces over time are going to damage and bend and malform the aluminum, especially when we're talking about niche applications where you need the copper to go or the wiring to go in certain shapes. That force can permanently damage that material and thus permanently damage the transmissibility of that material to move electrons or electricity, right? Also, copper is very easy to solder. So we're talking about niche applications in electronics, solar panels, etc. It's a lot easier to work with than aluminum. Aluminum is a lot more rigid and doesn't solder as easy. Yeah. In addition, yeah, we live on planet Earth, right? There's water on planet Earth. So anywhere where we have a solar farm or we have a wind farm, at some point it will likely be exposed to water. Copper does not react to water. However, aluminum does. So if we consider all of these advantages, it's hardly surprising that copper conductors come at a premium. But even if we consider the price increase on copper versus aluminum, copper is almost always still the more viable choice. Now that may change for some applications. If you see copper prices increase to the moon, in which I think that they will, we'll be forced to use some aluminum in some applications. But the choice material is always going, if we have to pick copper or aluminum, is always going to be copper, yeah. All right. So now let's get into supply. And I kind of have a video that kind of talks about this. So I'll start with that first.
It's also used for electrical wiring. In fact, it's used so much that in a country like the UK, each person has about 175 kilos of copper associated with each person in the piping, the wiring, and so on. The problem is that in many other countries, for example in China, people have very much less copper associated with them. There isn't so much electrical wiring in rural parts of China. And if everybody in China had the same amount of copper associated with them as those in England or America or Canada, there wouldn't be enough copper in all the known deposits around the world. Copper is found as a metal lying around in various places in the world. I believe the name came from the island of Cyprus in the middle of the Mediterranean, but copper has always been known. Even in prehistoric times, people found small amounts of copper. But as we use more and more copper, people have had to dig deeper and deeper mines. The mine in Chile, where those very brave miners were entombed for more than 2 months and then rescued, was a copper mine. And to get the metal that we need, we're going to have to go deeper and deeper and deeper into the earth.
Okay, so that was a professor at the University of Nottingham. He has a great YouTube channel devoted to chemistry, which I frequent, and I would recommend you check it out too. I think it's called Periodic Videos. In any case, what he was talking about was kind of the supply side of copper. And this is the other side of this story, in which makes me bullish on copper as well, right? So over here on my screen, I have a graph from which year cut off, but from around 1900 all the way to 2010, and it continues to 2020. The same trend continues. However, you may notice over here in the early 1900s, the grade of copper mines was quite significant. It went on a world scale. We went from, oh no, this is Australia, excuse me. The world scale will be orange. On a world scale, we went from about 4% grade copper in copper mines all copper mines on average had a 4% grade, meaning that for every, I don't know, we say pound of ore that was mined in that copper mine, 4% of that stuff was actual copper. Now you look over time, there's a trend that we're noticing, right? And in the world, as we are approaching 2020, 1% copper grades are has become kind of the average. So over 100 years, the amount of copper we can mine easily has been cut by 25%. So we've essentially, a good copper mine today, a good grade copper mine might be 1%, right? What this is telling us is that supply is declining over time. And in the oil industry, a similar thing has happened, but we've had technology like fracking that allows us to extract oil in sources that are less and less productive. But in copper mines, this is not the case. We don't have a shale revolution. We don't have something like that in copper. We still mine in much the same ways that we have in the past. So what does that mean? That means that supply is being constricted. So also, especially, this is why I'm not bullish on copper mines in the United States and Canada, we have further supply constriction from environmentalism, right? Which is kind of absurd, but all right, I'm trying not to keep it in, stockaholics, but we're not going to go on a rant here. But the whole reason we're going into all these electric vehicles is for environmentalism, right? But when you look in these Canadian and and United States, we're not permitting mining projects because of environmentalism. We don't want the environmental impacts to actually open these mines, right? So mining projects in the United States and Canada tend to be extremely unpopular, restricting supply even further. So we have some reasonable grade potential mines in the United States, but they are not, we're not exploiting them to the degree that we need to be able to match the coming demand in this material. So this is a project right here that kind of exemplifies this. There was there's a mine called the what is the company called? Shoot, I forgot the name of the company. But they essentially, it's a mining company in Alaska, and they tried to get a project going. Northern Dynasty was the company, and they have a mine project called the Pebble Project. Okay. We have political restrictions. So we believe even if this new mine plan is approved, the project faces near certain cancellation on environmental grounds. Joe Biden could not have been more explicit in his view of the mine when he said a few weeks ago, Bristol Bay has been foundational to the way of life of Alaska natives for countless generations, provides incredible joy for recreational anglers from across the country, and is an economic powerhouse that supplies half of the world's salmon. It is no place for a mine. The Obama-Biden administration reached this conclusion. Then we ran a rigorous science-based process in 2014, and it is still true today. The only reason we are still debating whether the Pebble mine should move forward is because, well, I'll let you know, they're not debating it. As of today, the permit to continue this project, the Pebble project in Alaska, was declined. They will not be able to advance this project any further. The copper, which we so desperately need to meet our environmental goals, because of environmentalism, we cannot further explore this possibility. So, anyway, because of all of these things, because of the increase in the demand, because of the constriction in supply, which we are seeing because of both environmentalism and degrading quality mines, we are going to see copper prices go to the moon. Now, I am investing in some copper companies, which are not based in the United States and not based in Canada. If you would like me to make a video on some of those, let me know in the comments below if there is some interest in this. Again, you guys have a good Thanksgiving, and I'm grateful for you guys being here today. Till next time.